All right. So, thanks for being here today. I hope everybody can hear me okay. So I will be the moderator for today's ENLIGHT lecture. My name is Chris. All right. So, thanks for being here today. I hope everybody can hear me okay. I have a problem. So I will be the, there we go. Okay, we're back. So, as I was saying, I'm moderating today's talk. I would like to remind our audience that you have no possibility to turn on your microphones, nor your cameras, but you can put the questions in the chat, and we will address all the questions during the discussion after all the talks. So, with that being said, I would like to thank every presenter that is here today with me. And without further ado, I think we will move on to the first talk for today. So I would like to welcome Itziar Alkorta with her talk, 5 Crucial Challenges on AI Regulation. Itziar is civil law professor at the University of the Basque Country. Her research field covers protection of medical data regulation, reproductive technologies, tissue donation, and personalized medicine. She's a member of the Consolidated Research Group on Personhood, Patrimony, and Family, with a vast experience on interdisciplinary research projects funded by European and Spanish agencies. Itziar, thank you very much. And without further ado, the floor is yours.
Thank you. I will try to share my presentation first. There it goes. I think that you can see it. Okay.
Yes, everything works fine.
Okay. I'll do it this way. So thank you. Hello, everyone. And thanks for inviting me today to this lecture series on digital revolution and society. And it is a pleasure really to share some insights about medical AI regulation with you. First of all, to give you this insight on the regulatory challenges the introduction of medical AI systems are facing, I thought of using a use case I am directly involved in. This is the Smart Beer EU large-scale research project. This is a platform aiming to integrate sensors, also assistive medical devices and mobile devices to enable continuous data collection from everyday life of elderly people with some conditions. These data are analyzed through AI algorithms, and they obtain some evidence in order to offer personalized intervention for these elderly people. So this is a rapidly expanding field for research, and inevitably these developments need to comply with some regulations before they can be marketed. The question is, what are the challenges that we are facing from a regulatory perspective to market this kind of devices? First challenge is interpreting the emerging regulatory landscape. Till now, as you may know, software-based medical products have stayed out of existing EU laws. But from now on, software can qualify as a medical product. The medical device regulation requires medical software to demonstrate performance and safety of the software algorithms. These certification requirements typically involved a risk-based approach. In some cases, the clinical evaluation will need to include a clinical investigation. This is the case, for example, of class 3 medical devices, invasive devices. But for all other medical devices, conformity may be demonstrated by the manufacturer based on sufficient clinical evidence. Our SmartBird project, for example, has been classified 2A. This is because it complies a blood pressure measurement and notification devices to the patient and the clinician. There is also a very important novelty in the MDR, and is post-market surveillance. We need to monitor algorithm performance constantly, collecting real-world data and implementing risk management after commercialization. But this is not the only innovative regulatory landscape that we are facing. We have also a draft AI Act that's well known and also implies AI-based medical devices. This AI draft tells special aspects of quality assurance of the AI components and evaluation of a specific risk potential in the context of conformity assessment of these devices. So there is a double difficulty in this landscape. First of all, identifying the classification that better fits the component or the device, but also identifying applicable requirements for each software component. Second, AI Act provides that individuals should not be subject to a decision that is based only on an automated processing. If this decision significantly affects or influences their personal circumstances, their behavior, or their choices. For example, an automatic processing may lead to the refusal of a health insurance. To authorize this kind of processing, the individual needs to explicitly give his or her consent. For this, informed consent should be in place, ensuring that patients have sufficient information to make autonomous decisions. This, as you can imagine, challenges the clinician that has to explain complex AI algorithms to patients and obtain their consent using AI technology in their care. For example, in our case, we need to explain the logic involved in the decision-making process of the algorithm, the right of the patient to obtain human intervention, also the potential consequences of this processing, and the right to contest or oppose the decisions. In the third place, another challenge that AI systems pose is privacy and control of patient data. As you know, the use of innovations might entail collection and evaluation of data, such as usability surveys or routine medical data. It is our experience in the digital innovation field that it is difficult to know what kinds of consent are appropriate in these situations, what permissions should be sought from pilot testing individuals. Especially, we face difficulties with reduce of collected data. As you may know, scientists have for long claimed open access to pseudonymized health data for research. General data protection regulation does not fully specify requirements that controllers must comply to be authorized to use secondary processing of health data. For tackling with this handicap, a new legal framework has been announced in order to share health data for research and innovation. The first legal instrument to be adopted has been the Data Governance Act. This DGA develops a new framework for companies and individuals to engage in data sharing in secure environments. This framework, based on the creation of a trusted and independent intermediaries, aims to facilitate data sharing between data subjects and data holders. An emerging trend on this domain is to seek increased patient engagement, treating the patient as a stakeholder in research and not just as a data source. So the regulation also introduces a new concept, data altruism for the general interest, based on the idea of voluntary sharing for the common good by data subjects. It will be implemented through data altruism organizations. And lately, in May 2022, the European Commission proposed a new regulation to create the European Health Data Space. The law attempts to improve the ways in which people's health information is made available for treatment in secure environments and also for research. This model is being discussed at the moment. This incoming framework should make data sharing easier for researchers without compromising patients' privacy and data protection. Finally, another challenge, or in the fourth place, another challenge means minding the source of training data sets. This is important for addressing potential bias of the data to ensure fair and equitable healthcare outcomes. We are bound in our projects to use strategies for mitigating this bias, such as diverse and representative training data, algorithmic audits, and ongoing monitoring. The new legislative framework makes also the user responsible or liable of the outputs of the algorithm for biased training of the device. And this is an absolute novelty in our regulation. Finally, accountability of AI algorithms in medical devices is also an emerging area. New product liability directive draft will consider that AI-based software is qualifying as a product. The actions and decisions of algorithms can impact patient outcomes, making it crucial to evaluate algorithms' role in adverse events or even errors. AI-based medical devices introduce unique legal challenges due to the involvement of multiple stakeholders. Also, because sometimes complexity of AI systems can make it challenging to assign direct liability. Establishing a link between the damage and the cause may involve a thorough investigation, which could include evaluating the quality of the algorithm, integrity of the data used, training process, etc. All this is extremely difficult to afford for the patient. That is why the Product Liability Act proposal is lowering the standard of proof. It is even inverting the proof and the causality when there is an actual damage. The one who should prove the causes is not anymore the patient, but the liable producer or the liable trainer of the device. Also, compulsory insurance systems in place should be for risk AI-based medical devices. And implementing transparency measures such as documentation of the algorithmic decision-making process and providing explanatory for outputs is also obligatory. As for the final remarks regarding medical AI adoption patterns, I think that this is a question of principle. These adoption patterns of medical AI depend on political and juridical settings, and technology adoption should respect fundamental rights, of course, but also at the same time incentivize for innovation and having a balance between these two principles. So in the end, where to put this balance is a decision of which technology we adopt, which technology we reject, and it always should be an informed and democratic decisions for all. To wrap up, we have gone through the 5 crucial challenges, in my opinion, for medical AI adoption at the moment, which are evolving regulatory landscape, transparency and explainability, privacy and data protection while fostering health research, preventing bias of data, and new liability regime. These are also some sources that I used for this presentation that you can have online, and also regulations and recommendations for further research. Thank you very much.
All right. Thank you, Itziar, for this great presentation. It was very insightful. So I'm excited to continue with the next presentation now. So our next presenter is Cornelia Connolly, and the title of her talk is The Robotic Revolution, Social Robots in Education Explored. Cornelia is an associate professor at the University of Galway and an established international scholar in computer science education. Her research interests focus on broad societal impacts relating to computing education and digital competency, digital education and innovation policy, CS equity, and knowledge transfer to facilitate behavioral change in a variety of learning. So, without further ado, Cornelia, the floor is yours.
Thank you very much, Chris. Thank you for that introduction. Thank you to our ENLIGHT colleagues for the invitation to present today. And yeah, so our topic was around digital revolution and society. And I'm going to talk a little bit about social robots and some challenges and questions in regards to their introduction into education. Going ahead. So increasingly robots, humanoid robots, as shown in the diagram, semi-humanoid, they have a special appeal in education and enhancing the interaction with the content user and the content producer, so the student and the teacher, along with presenting materials. And we're really in a new era of robots and robotics, similar to how the personal computer was introduced many years ago, in that really personal computers are a consumer driven, and that each of us in most of our homes have now, and the same will occur or is occurring in terms of robots. This new era of robots really sees us having many more within our home and educational settings. And they are providing essentially more social and cognitive support to each of us in different guises. In recent years, work by Chris Hoadley and his colleague for the Spencer Foundation, they really defined the 4 major developments in terms of technology that's affecting education. And we've seen that evolution from the rise of pervasive total data to VR and AR experiences, to deployment of AI and algorithms in the processing of big data, to now really that ubiquitous technology and accessing the digital divides and ensuring that that everybody has access to these technologies. But technologies are becoming more pervasive in our daily lives and integral to our daily lives. And the same is true within education. Traditionally we probably have seen robots as used as tools, but now we use them more as social partners. And first and foremost, I'm going to say too, they're never going to take the place of people and or of teachers, but they are going to have an important role in supporting populations who need extra assistance, whether that's young people or children learning a new language, aging adults who are struggling with their memory or who forget a little, or indeed children with autism spectrum disorders who are struggling to learn social behavior. We have really seen advances in our research where robots play an essential role to all of these target populations. And there's some great opportunities for robots to learn to make substantial difference to these people and to us as people. And also they bring enjoyment along in the process. So in so many regards, educators' roles in school settings or in educational settings are intertwined with their relationships to technology in the classroom. And so I want to pose, I guess, some questions in my talk today and reflect on socially assistive robotics in education through a critical but positive lens. Like all good lessons, I'm starting with this learning intention, and really just to present, I want to present some questions and a critical analysis of how robots and AI is really influencing and could influence our education, and things that we need to maybe probe or question. We're really driven by a need to keep at the pace of techno and socioeconomic requirements. Schools and society are increasingly adopting AI and robots in their daily action, whether that's ChatGPT, OpenAI, LLM, large learning machines, large learning models of AI. They're all influencing our education sector and ecosystem. And there's a really interesting ontological tension between the models of education that educators have and the models of education that computer scientists have. And I suppose in my own work, I cross that divide. And so hopefully pose some questions today and maybe probe. To start with, when I'm talking about education, I think it's important to kind of just contextualize. Education is the process by which people deliberately support learning, including not only formal primary, secondary, third level higher education, but also that education that occurs in the workplace, self-study, the informal, non-formal learning context. And when I refer to education, I'm referring to this whole ecosystem. So not just the school context or at the university level context. And robots and robotic usage can contribute to education in many different ways. It's been proven that they can provide great benefits as a learning tool, that they can facilitate learning, and that they also support the development of 21st century skills such as critical thinking, and they've been really, and problem solving, and they've been really incorporated in a lot of ways in terms of for STEM education, as an example. And we at the University of Galway have done some research in terms of using humanoid robots to promote hand hygiene in hospital settings, and also in terms of digital health education for diabetes education. But technology and robots adds a level of complexity to any pedagogical context. And that's what I want to probe today. So it's important that though there's all these positives to technology, there's also negatives, and it's being aware of the constraints, of the boundaries, and presenting that or being conscious of it in our educational setting. And we should always think about, I suppose, how technology may exclude, and also being conscious of the educators' increasing understanding of the students' learning needs. So firstly, looking at data and AI and the implications for education. Machines, technology, computers gather our information, and AI is hungry for data. But we also need to be mindful and conscious that data is imperfect. It's about the past, and it can be biased. But data is what makes the computing useful and valuable, powerful, but also harmful. And so from an education point of view, we need to think about how AI and data is increasingly becoming that engine of education, and student data is that fuel. So are we providing education on platforms, or is it platforms in education? AI will increasingly become the engine of education, and we need to pay close attention to the faith of some of these educational platform providers, to who is driving, I suppose, that AI backend, the giants that are influencing our education system. And in terms of even when we think about machine, three important questions that we kind of need to consider fundamentally, what, where, and how is gathering our data and influencing our learning, whether that be via robots or not. But so where is the most significant and influential learning happening in our society? Is it still in the classroom in formal education, or is it external to that? But how does formal education maintain its role? What kinds of systems are undertaking learning? And how is our learning intermingled with the ways that machines learn, how machines are learning? And that is going to influence next generations as well as current generations. The work of Susanna Zubkov in her book, The Age of Surveillance Capitalism, really kind of extends that and positions or questions the idea of our traditional formal learning, and highlights the extent to which we need to be cognizant and expand our horizons. She talks about or raises questions about the distribution of knowledge and whether one is included or excluded from the opportunity to learn. And if we think back to my second slide there by Chris Hoadley in terms of the digital divide, are we including everybody in the availability of our technologies and of our robots within our education system? My second question, or that I want to pose, is regarding partnerships and collaborations and who's creating the agenda. There is a commercial ecosystem that exists and that's tremendously influential and takes place in educational technology. Educators need to pay close attention to the faith of these educational platforms and to the providers. But who's driving the global education agenda, and who's regulating and who has oversight of these activities? Digital learning environments make partnerships easy to envisage and execute, and that's really important, but we also have to be mindful of it. We need to think of the commercial actors that are supporting public education, and we also need to think of our role and how educators are supported in maintaining our role in guiding and the development of education and the most vulnerable members of society. My third point is regards limits. That technology and computing is not free, it's powerful, but there is a finite resource there. And we have to be mindful of that. So computing within limits is a topic and that is evolving and gathering steam. And it's really, thinking about that global society and shaping our society and how we work within our limits. And the plan within all computing and all technology affecting our education system, there is a finiteness, as I said. So in terms of steps forward, and sorry, I'm rushing now, but our learning cycle is longer than the technology cycle. And unfortunately, within education, sometimes we can't keep up at the pace at which technology is evolving, but we have to be active agents in those innovations and in the design and development of robots and socially assistive robots, especially. I think when we are reflecting on robots in education, we need to think about the core values that underpin all our work, what assumptions we're making about our learners and learning, and what models of pedagogy does it promote and will it support within our classroom, within our lecture theatre, within our educational context. We need to actively design the technologies for that equitable future for everybody. We need to explore human learning and thriving in a variety of contexts, but we also need to re-establish the value of formal education within an era of ubiquitous learning. And we need to cultivate equitable education spaces with a variety of technologies and ensuring that everybody has access to these technologies. I'm going to end on a quote by Neil Selwyn that talks about care rather than competition, cooperation rather than rivalry, and imagination rather than corporatized creativity. And I think the ENLIGHT network really symbolizes that, and it encourages me and encourages our colleagues to really to pioneer this area of research in terms of socially assistive robotics in education. Thank you very much.
Okay, thank you so much, Cornelia, for these very interesting insights. I'm looking forward to the discussion. which leads us to the last input for today, which is given by yours truly. So a few words about me, perhaps. So, as I said, my name is Chris Warin. I am a PhD candidate at the Computer Security and Privacy Group at the University of Göttingen in Germany. And over my studies, I would say that I got passionate about social and human aspects, especially when combined with computer science. So this kind of naturally oriented me towards topics such as privacy and security during my studies. So this eventually led me here. And so this is why my talk would be about privacy and security in extended reality. So I'm just going to share my screen. All right, so I hope everything works fine. And I will just start. Okay, so the title for this talk is Usable Privacy for Extended Reality, or XR, in the Era of the Metaverse. So there are a few keywords in this title that I'm going to try to explain over the next few minutes. So let's start with the basics, shall we? So what is XR, or extended reality? Well, it's actually an umbrella term that we use to refer to a variety of other technologies that you might know, such as augmented reality, mixed reality, and virtual reality. So here we have a few examples of such devices which come in various shapes and forms. So you might know, well, AR from smartphones or for tablets, maybe, in applications such as Pokemon Go, which was a famous AR game a few years ago, or even through Google products such as Google Maps or Google Translate. You know, when you hover your phone over some text to be translated and it does it on the go, well, this uses AR. You also have a lot of headsets. So for example, this on the left, the white headset is a Meta Quest 2. It's a VR headset. And the black one on the right is a Microsoft HoloLens 2, which is more used in the industry because it has transparent glasses and you can put things on top of that. So it's used in surgery, for example. So if we took a look beyond the glasses, this is typically the content that you would see with one of those devices. So AR consists in projecting 3D shapes or objects on top of reality, which is why it's literally called augmented reality. And mixed reality is a little bit similar. It's the same principle, but I would say it's maybe AR 2.0. This is sometimes how it's seen because you have more interesting inputs. For example, you can use your hands to grab holograms, move them around, so it's more immersive. So this is sometimes how it's referred to. And lastly, I think the third one, VR, is a bit easier to grasp because here you simply shut yourself from reality altogether and you wear a headset, you don't see your surroundings, and you are completely immersed within a virtual world. So that's it for the basic definitions of XR. And now I'm going to go over with metaverse. So you might also have heard about this in the recent years from Meta, probably, which branded itself like so literally to propagate this kind of universes. But actually, the metaverse is not really a new concept. It's something we've seen since the 90s. It was coined first in Snow Crash, which is a novel, and it describes immersive, realistic virtual worlds, which are platforms for people to socialize, play, work, learn together, and so on. There are a lot of uses, and typically those are hybrid and intertwined with reality spaces. So the idea is that you can easily go from reality to virtual worlds and back and forth with a variety of devices. And this is the idea that we've seen in fiction. And from fiction, we are slowly going towards reality. Well, we're not quite there yet, but actually we still have a lot of investments from technology giants, big players like Facebook/Meta, Microsoft, Apple, and so on. So they really want to spend billions so that what we had in fiction becomes our reality in a few years. This is also a hot topic in research. For example, since 2023, if you look at metaverse on Google Scholar, you will get more than 10,000 results. It's a number to take with a grain of salt because it doesn't necessarily mean 10,000 peer-reviewed publications, but I think it still kind of shows that it's an interesting topic for researchers. And we've had actually premises of these virtual worlds with examples such as VR chats, social networks, where you have avatars that look at after what you want and you can interact with people online. So I think it's just a matter of time before we actually get there. And if we look at the industry, well, the market size has been going basically bigger and bigger every year, and it's expected to basically double by the next 2 or 3 years. Like I said before, it's also something to take with a grain of salt because these are only forecasts and it doesn't always live up to the real numbers, but still an interesting insight. So you might tell yourself, well, we have this new fancy technology, we can do a lot of things with them. The industry is booming, the devices are becoming more affordable. What is there not to like? And well, the title of the talk also contains privacy, so I think it gives a little hints there. And indeed, when we think about privacy, there is a lot of things to consider. So basically, the problem when it comes to privacy aspects with the metaverse come directly from XR devices themselves, because they are the technical backbone of the metaverse. And so these devices have a lot of sensors, and in fact, they have been having more sensors for years. Every new generation of devices has a lot more sensors than the previous. For example, a few weeks ago, Apple revealed their new AR headset that should launch next year. And it has a nice cocktail of sensors, including 14 cameras, a LiDAR sensor. This is normally put in cars to detect objects. It has also an accelerometer, a gyroscope, a variety of microphones, eye trackers. So the more sensors you have, the more data is collected. And the fact is, these devices have been more and more collecting biometric data. And biometric data is typically data about you that you create yourself from your movements, your eye movements, your voice, your expressions. So this is very sensible data that can tell a lot about you. And all of this data is collected by these devices. For example, your movement data can be collected from wearing a headset and wearing controllers. Your space and your position in space can be replicated and obtained when you play a VR game, for example. And so this has been shown in research that such data can lead to user identification when it's given to machine learning algorithms, for example, which can identify users with over 90% precision with just a few minutes of data. So quite sensible. Also, when it comes to eye trackers, we also have sensible data at stake. We know from psychology, medicine, that eye tracking data contains a lot of sensible personal information. This can include your gender, this can include your sexual attractions also. And if you consider putting this in the hands of Meta, who on the one hand have biometric advertising patents, and on the other hand, their newer headset, which has integrated eye trackers, you might want to think twice about using this kind of devices. So there's that. And we also have more and more realistic real-time facial animation in VR social networks on Horizon worlds. I think they're starting to incorporate this. And so if you consider that your movements are replicated, your eyes are being tracked, and your facial mimics are being replicated in real life, well, you end up with highly realistic digital twins, which are literally avatars made after yourself. And so with this, you have a growing loss of anonymity online in this new paradigm. So yes. And if we think about something else than biometric data, you can also think about security, safety aspects, ethical aspects. You might have heard about virtual sexual harassment, which It's horrible, but in 2023, apparently it's a thing. So this is also something that needs to be taken care of. And thus we have, as researchers, a lot of work to do. So when it comes to privacy in XR research, I would say that there's maybe three main pillars. Obviously, you can find more, but I would like to concentrate on these three. So the first and most obvious one, perhaps, is threat modeling, which is what has been done in the last 10, 15 years when the technology was still very nascent and very at its dawn, basically. So we were thinking about potential threats that could arise in a few years when the technology gets there. And now that the technology got there, we are moving on from potential threats in a very abstract form to more concrete threats. And so now we are stepping into the second pillar, which is now is the time to understand users' privacy perceptions and raise their awareness about data collection aspects. So this is the work that we do at our lab, and this is the main point of my research. So we are trying to compare users' privacy behavior and their awareness across different XR platforms to see if they have different perceptions. I'm going to talk about this more in a minute. And lastly, the third pillar is obviously to implement new privacy preserving solutions so that we can better assist the users who use these technologies. So the idea here is to fill the gap between what users need versus what they have concretely. So if I look a little bit more into our research here at the Computer Security and Privacy Group, right now I'm conducting studies, and the research question for the study is basically the following: what are the differences between AR, VR, and MR in terms of user privacy perceptions? And we can see this from two lenses. The first one is to observe the privacy perceptions with respect to hardware, basically see the mental model of XR users regarding XR technology and devices, see what is their awareness regarding data collection aspects, also their willingness to disclose data to other parties. And so this is the first study that we are conducting at the moment. And the other lens in which we can read this is privacy perceptions with respect to social context. So this includes the behavior of users when they interact with other users virtually. And here we can see or seek to observe their sense of physical privacy in a virtual context. And this will be another study. Right. So another word that is in the title is usable, for usable privacy. And this links directly to usability. And so you can ask me, why do we need usability? The thing is, like I said before, we need to understand user privacy perceptions so that we can better assist them. And for this, we need to design a lot of things. We need to design applications, solutions, and also studies themselves so that we can, first of all, explore the people and explore the situations. And then we can design solutions to inform and support privacy. And to do this properly, we need user-centered design. And user-centered design is a main value that you have in usability. And so another point is that in the metaverse, we will have increased interconnectivity between the different devices and vendors. Maybe I'm in the street tomorrow with my fancy mixed reality goggles, and I see the projection of someone in front of me, and I'm chatting with them. And the person I'm chatting with is at home with a VR headset. So we will have different devices at different points in space and different operating systems. And so because everything will be so different, it will be hard to enforce native solutions that look all the same. So we need something that looks the same and that works on all devices so that we can propagate this to as many users as possible. And to do this, we will need to provide users with a sense of familiarity, learnability, and memorability, which are essential features of usability. Right, so this leads me to my conclusion for this talk. So I try to show that XR is becoming more widespread and devices have an increasing amount of sensors. Privacy in XR research aims to raise user awareness and implement privacy preserving solutions. This is also what we try to do with our work. first of all, we want to understand the privacy perceptions of users through the lens, notably of these interconnected XR experiences. This is why this is called in the era of the metaverse, because this is the situation that we might end ourselves in. And hopefully all of this will contribute to filling the literature gap that we have at the moment on user privacy perceptions in XR, so that in the future we can create more solutions to help XR users. Okay, so this is it from my side. I have put a few references, and I would like to thank you very much for your attention. And now I think we can go to the discussion part with all the presenters, and I can ask all the questions that have been put in the chat. So thanks so far for your presence. Okay, so let's see. We have a question from Marius to Cornelia. You said that teachers won't be replaced by robots. Right now, this is partly happening just by normal recorded videos where researchers are not in class. Maybe I don't get it right. I would be glad if I do.
It's okay. Thanks, Chris, and thanks, Marius. Well, if I interpret it's a great question, and if I interpret it correctly, you're talking with regard to asynchronous versus synchronous learning. And I suppose your question is regarding just by normal recorded videos for researchers are not in class. But I wouldn't equate that to what socially assistive can do in an education setting, where they will prompt and support a learner step by step through their education or through their learning. Whereas you're referring to just a pre-recorded material made available to the student, if I'm understanding the question correctly. So I think we're two different spaces. Yeah, thanks.
All right. So if we get an answer, maybe I can get back to you later. In the meantime, maybe I have some questions. Actually, I had one question to Itziar. So you talked about data collection and privacy aspects when it comes to medical data. And I was wondering if, so you talk about these legal frameworks, and I was wondering if researchers can have a weight in the discussion for the creation of these legal frameworks when it comes to balancing research and privacy protections.
Thank you. Yeah, that's a great question. And in fact, we are posing that question every day when we are doing not only medical research with sensitive data, but also other kind of biometric data research. You know, the main problem is that we have very interesting regulation, European level regulation, that's the GDPR. And it unfortunately has not settled the question. It was a demand of researchers to have a harmonized regulation, and it hasn't happened. In this question, especially sensitive data, states have a lot to say. So what we are finding is that when we do, for example, international research, and that's very usually in medical devices, we have different frameworks for the main data in every state in Europe, throughout Europe. So researchers should be aware of that handicap that we have. And when, as you say, balancing reduce of this data for doing research, biometric data, for example, the GDPR asks to balance the interests of the research and the privacy issues. And when possible, you need to use pseudonymized or even anonymized data. Anyway, how to balance these two principles depends on the framework, on the state framework you are in. For example, you have a very stringent and informed consent-based framework in Germany, and we have the opposite in Spain, because you can very easily do research on medical data in Spain if you pseudonymize data. You don't even need the informed consent of the patient. So to have a balance of these two principles depends also on the culture, on the regulatory framework of each state in the union. And finally, we are discussing this actually at European level, just to create the European health data space. And one of the main issues we are discussing is that, can we use open consent for reuse of sensitive data? Is that an output that we are ready to have in Europe, sacrificing security and privacy to foster research, or we want a more conservative framework? So this is now an issue at Europe, and there are a trilogue, a dialogue between the Council, the Commission, and the Parliament discussing on these issues.
Yeah, that's very interesting. I didn't know that there could be such big differences in how consent can be asked within countries that are both in the EU. And thinking about this, I realized that we actually, the three of us, we have this problem of balancing privacy and user data and the devices that we use or in the context. So it's the same for you, Cornelia. That brings me to another question I had. You talked about data collection, robots, education, and I was wondering who should have the responsibility to ensure that the data is as unbiased as possible, and how or who ensures that. And also I wanted to say that I was happy to see that bias in data that is fed to AI is considered, because I think it's not considered enough. So that's good.
Yeah, I think they're really good questions. I'm not sure if I have the definitive answer, Chris, but there's certainly questions that we have to pose. And I think that sometimes we forget, or we're not conscious of asking these questions. And yeah, our data, being mindful of that, making our students aware as the technologies evolve and as data becomes more precious, that they're really important questions to ask. If you think of any of the big corporations over the last 50, 100 years, data is now the commodity, the most valuable commodity of all of these companies, and in their evolution. And so as educational institutions, as universities, that's something that we have to be particularly mindful of. But at the same time, we have to embrace technologies and robots in our classrooms and be ready to create an awareness around artificial intelligence, ChatGPT, OpenAI, LLMs. They're all really important to us, and we need to facilitate their evolution, but being mindful of the boundaries and constraints in which they operate.
Yes, and especially for the younger audiences, like teenagers or kids in schools, because they will be faced with this from a very early age, and I guess they're also more vulnerable to this. Okay, thank you very much for both your answers. Perhaps we have more questions. So yes, actually there was a question for me from Alexandra. which is what challenges arise in balancing privacy concerns with the need for data collection and analysis to enhance XR user experiences. So we're still on the same topic about balancing privacy concerns or the data collection, and yeah, it's I guess it's like a challenge for every domain. Like for us, the thing is, as soon as you disable camera usage, for example, automatically the devices can't function anymore. It makes me think of something quite interesting. I'm developing this cross-platform application at the moment for multiple devices, and they mostly run Android or something similar, and they have, you know, this access permission prompts when you start the application. Oh, do you want to authorize camera usage or microphone usage? And the funny thing is that when you run it on the Android smartphone, it asks you for authorization of the camera. You can say no, and then obviously it won't work. But for the Meta Quest, so the VR headset, it doesn't even ask for the camera authorization because it could not even turn on without it. So there are obviously, you know, compromises that need to be done, because you cannot just cut some aspects of the data collection. But I think the best compromise is to, at the end of the day, let the users decide themselves. Sorry, and this is some path that we're trying to explore, to create a man in the middle, but not an attacker, obviously, a man in the middle, which would be in the form of some API or an application in which users can choose their own preferences, and that would actually apply a final decision between the applications that implement this framework and the devices themselves. So in the middle, so that if the user decides that no, they definitely don't want the application to use, say, the eye tracker, then there's no way the application will use it. So this could be one idea. All right, so I have another question or another point from Marius. So I think it goes back to the first question that was asked to Cornelia, which, so they're saying, my point is, if a normal videos are able right now to replace them, and we learned from Chris that it's possible to make digital clones of a person. So why should it not be possible to replace them fully? So the teachers, I assume. It's a very interesting topic for me, and on the other hand, it fears me a bit. So, for example, Major, who thinks they speak with Vitali Klitschko, but that speak with a deep fake instead. Yeah, I agree that deep fakes and these in AI in this context are going to be a big problem.
Yeah, I think though, and I'm not an expert in deepfake and at that space, but in terms of providing videos as tuition, they're there to support what the educator provides in a live synchronous session in most educational settings. So I don't think they replace them completely. We'll still need humans to educate other humans, and we'll also need humans to develop the materials that ultimately AI or machines will regurgitate and reuse or provide to others too. So humans will always be needed in that context, and particularly, I suppose it depends too on the phrasing. And when I'm talking about that robots will not replace teachers, I'm talking about it in a traditional school setting. Maybe in an informal context, you can see where there may be socially assistive robots will support what's going on within a classroom setting or within an informal learning environment setting. But I don't think they're going to replace a teacher within a school setting.
Okay, thank you very much for your answer. And it's perfect because now we are ending the session exactly at 4 p.m. So we are right on time. So I would like to thank once again all my fellow presenters that came and took their time today to give us these very inspiring talks. And also thanks to our audience with very interesting questions. And now I would like to invite those of you who are registered to the networking event to switch rooms. So thank you very much and see you in a bit.